I hope you've gotten enough time to watch most of our videos, right? And today I would want us to basically use this lesson for a recap to see how good are you following most of the videos which are online. And I would want us straight away to look at a 3x3 matrix focusing on input-output model. Input-output model. Now, for me to be able to pin down this model very well, you must be good at getting an inverse of a 3x3 matrix. So I would want, first of all, to get a response from you great students of mine by knowing how many of us are able to derive an inverse of a 3x3 matrix. And I would want to start with Mr. George. Please unmute Mr. George. George Simeon. Mr. George, have you? He's not in, eh? How about Paris? Paris, have you gotten some time to watch your videos on matrices, especially on how to get an inverse of a 3x3 matrix? Yes, Paris. Okay, Abdi joined us just the other day. I don't know whether Abdi has gotten some time to watch this video on a 3x3 inversion. Abdi? Okay. So then allow us, ladies and gentlemen, straight away to just tackle this area, all of us. So if you're given here matrix A, which is 3, 2, 1, 6, -1, 4, 3, 1, -2, like that. This matrix has got how many rows? It has got 3 rows with how many columns? 3 columns going down. 3 columns going down. So it's a 3x3 matrix, and we are required to determine the inverse of that matrix. So remember the basic steps. Basic steps, ladies and gentlemen, of inversing a 3x3 matrix. Number 1, you give us the determinant. Number 1, the determinant. Number 2, you give us what we call the minor elements. Minor elements. Number 3, you give us the cofactors. And then number 4, lastly, you inverse, or rather the inverse. 4th step is definition of the inverse. Inverse definition. Inverse definition. So we shall start right away with the first one, where we shall come and give us the determinant. Who can remind us the formula of getting the determinant? Remind us the formula of getting the determinant. Somebody, unmute all of them. I want to see whether there is somebody who can give us the determinant formula. The formula for getting the determinant. Somebody talk to us. How do we get it? Great. You students are great students. Kindly just talk, even if you are wrong. So what? It's part of the game. If you have not watched those videos, you simply tell us we have not watched them. We have not gotten the opportunity of watching them. And we shall be able to understand, because also we know that we are taking care of interests of students who are very busy at their workplaces. Although regardless of how busy you are, given those pre-recorded videos that we have given you, we expect you to be watching them piecemeal, a few videos every other day. So ladies and gentlemen, to get our determinant, we normally take PPD. We normally take the PPD minus PSD, product of primary diagonal minus product of secondary diagonal. Product of primary diagonal minus product of secondary diagonal. Product of secondary diagonal. So for us to be able to define these diagonals very well, we must come and write this matrix here. We have 3, 6, 3. We have 2 minus 1, 1. We have 1, 4, negative 2. So there are many methods, but the very best method is the one where you will come and duplicate the first 2 columns here. So we have 3, 6, and 3. And then we have 2 minus 1, and then 1. So you duplicate the first 2 columns besides the main matrix. And because this is a 3 by 3 matrix, we expect, ladies and gentlemen, us to have 3 diagonals. The first diagonal is normally the one that starts from the first element of the entire matrix and runs across 3 elements. So that is the first primary diagonal. And then, ladies and gentlemen, a 3 by 3 matrix has got 3 primary diagonals. So the first one, already that is down. So come and give us the second one like that. And then now we have the third one like that. So give us what we call the PPD. PPD is product of primary diagonal by basically multiplying the primary diagonal elements. Like the first one will be 3 times -1 times -2. Plus the other primary, which is 2 by 4 by 3 by 3. Plus we have here 1 by 6 by 1. Product means you're multiplying. So please give us that answer. So this answer, what do we have? 3 times -1 times -2 plus 2 times 4 times 3 plus 1 times 6 times 1 equals, I'm able to get 36. That is product of primary diagonal. From there, come and give us the product of the secondary diagonal. Product of the secondary diagonal, identify the lagging. These are the diagonal which goes through 3 elements, starting from here now, like that. That is the first one. We have this one here, which is parallel to it. And then lastly, we have this one like that. So product of secondary diagonal, the first one, we have here 3 times -1 times 1. That is the first secondary. Plus the one that is parallel to it, 1 times 4 times 3, that one. Plus the last one, which is -2 times 6 times 2. Come and give us a figure. So what do we have? We have 3 times -1 times 1, first one, plus 1 by 4 by 3, plus -2 by 6 by 2, which gives us -15. From there, come and, ladies and gentlemen, plug in the figures that you have in this formula for you to be able to give us the determinant. To get the determinant, we have product of primary diagonal minus product of secondary diagonal. So product of primary is 36 minus the secondary diagonal, which is -15. So we have 36 minus -15, which gives us 51. So please unmute them. I would want to see whether we are together up to where we have reached. Are they getting the same answer like Mwalimu here? Somebody talk to me.
Yes, I got the same answer.
51. Thank you very much, Paris. How about Fred Macau?
Yeah, I got the same answer.
Thank you very much. So we have been able to do the first step. I want also to get feedback from Abdi. Abdi. I would want to see whether Abdi got that answer.
Yeah, Malim, I got the same answer. Thank you.
Great. Thank you very much. Now, the people who are following us on Facebook, we expect you to also be commenting. Yeah, we expect you to be asking questions there, right? So we have been able to get the determinant. So determinant, I'll save my answer somewhere here. My determinant equals 51. Now, from there, we go to the second step, which is the step of minor elements. So, ladies and gentlemen, how do we get minor elements? What are minor elements? By definition, minor elements are those elements which happen to be determinants. Determinants of submatrices. Determinants of submatrices. So we have, ladies and gentlemen, a minor element. A minor element. How we are writing a minor element is the determinant. Is the determinant. Is the determinant of the submatrix. Of the submatrix that is left. That is left after covering the row and column that define a specific matrix value. Now, because here we have got 9 values, ladies and gentlemen, we are going to have 9 minor elements. And how do we get these minor elements? Please read your definition again. We are saying that we normally get minor elements by using what we call hide and seek method. By using what we call a hide and seek method. Hide and seek method. Hide and seek method. So how do we do this hide and seek method? Very easy. Come and write your matrix here. So we have 3, 2, 1. We have 6, -1, and 4. We have 3, 1, and -2, like that. So if they want us to give them the minor element of this value, what I will do is to hide the row which defines it and the column. So we hide the row and the column that define the specific value. So this value is in row 1. So you hide the row and you hide the column. By doing that, we'll be left with a sub-matrix. And once you have this sub-matrix, to get the minor element of this figure that is hidden here, you give us the determinant of this. Remember, determinant is product of the primary minus product of the secondary. So we'll talk of -1 times -2. Remember, primary is the one that starts from the first element here. First element of this submatrix is this minor. So you have -1 times -2. And then now minus the secondary. Secondary must always be put in brackets. So you're saying that our minor elements will be equal to, so we have here -1 times -2 minus product of the secondary, where we have 1 times 4, you close. You say equals. I'm getting the first minor element to be negative what here? -2. Now from there, ladies and gentlemen, you go to the second value here, the second value of this matrix, and hide it. Remember, it is hide and do what here? Seek. It is hide and seek. It is hide and seek. It is hide and seek. So ladies and gentlemen, straight away, using my hide and seek concept, where are we? So what I'll do, I'll come and write my matrix. So I have my matrix here. So we have 3, 2, 1, 6, -1, 4. We have 3, 1, of course, the moment you get used to this exercise so much, like myself, you don't have to keep on writing. So I want to get the minor element of these 2. How do I do it? Look at the row and the column that defines it. So this one is in row number 1. So cover it like that. Cover the column which also defines it like that. By doing that, I'm left with 4 numbers. I'm left with a sub-matrix. So this sub-matrix, what do I do with it? I want to get its determinant. How do we get determinant? The first So we have our primary. So our primary, it is 6 times minus 2 minus, always open brackets for the secondary. For the secondary, always open brackets. So in this case here, if this is my primary, my secondary will be 3 and 4. So 3 times 4, close, which gives us negative 24. Go to the next one. The next one, ladies and gentlemen, I should be able to do this really without even putting any line. So we have 3, 1, and minus 2. So now I'm at this third figure here. So then I should be able to visualize by just the use of my eyes alone. I should be able to visualize that this is in row 1. So this one here should be covered, and this one should be covered. And the moment I do such a visualization, I should be able to see the primary left uncovered. So the primary left uncovered here will be 6 times 1 minus open brackets here for the secondary. So if these are my primary, my secondaries will be 3 times negative 1. And I've been able to put my secondary as usual in brackets, which gives me what here? 9. So now, my great students, I want you to do me a favor. I want you to go to this fourth element and give us its minor element. Go to the fourth and give us its minor element. And specifically, I'm focusing on my students who are on Facebook. The ones who are on Facebook, this time round, it is your turn for you to give us an answer. In your comment, I want you to give us in your comment section there, I want you to give us the minor element for this fourth value, which is 6. Quite easy. You will hide it row-wise and column-wise. Hide it row-wise and column-wise. Hide it row-wise and column-wise. Thank you very much, Mwalimu Edwin. Edwin Ochoi is a great partner of this particular venture, and we are happy that you are also following. And then we have this student who got it right, called Ikube Michael. There is a question I asked, and he had gotten 51, the same figure. That is quite nice, quite good. So now I'm waiting upon Michael Ikube and his colleagues who are watching us on Facebook to give us this fourth minor element. And of course, for my students who are online, these students of mine, Paris, Fred, Abdi, we expect you even to have finished all of them. So these great students of ours who are following us on Facebook, please, I'm waiting for this particular minor element here, minor element of this value 6. I want to see who will be the first one to get it. And then we give them a present. We give them a present. During this Corona period, presents are not bad. I want to give somebody a present tonight. And please, the Facebook followers of ours, try to share this particular post on your timelines. Promoters bring on board most of, or rather your friends. Sharing, of course, is caring. So I'm not seeing anybody who has been able to respond on Facebook. Perhaps most of them may not. We have Lenny Langat has given me a figure of -3. Thank you very much, Lenny Langat. Is there any other person who has been able to get this same answer, -3? Any other serious student who has been able to get this same answer? My students, after school students, is this answer correct? -3. Abdi, what answer do you have there?
-5.
-7. -5.
Abdi, -5. Paris, -5.
Yes.
Okay. So in this case here, and Kenywa Junior got -5. So Lenny, you must have messed up with a sign. Look at this. When we talk of this fourth value, Please, the first thing that you need to do is to hide the exact value row-wise and column-wise. So if I hide it row-wise, this row is gone. And the column-wise, this column is gone. So then I'll be able to spot the primary, which are left, in this case, ladies and gentlemen, the primary, which are left uncovered. These are the primaries left uncovered. So I have here the product is 2 times minus 2. Minus always open brackets for the secondary. If these are my primary, then my secondaries will be 1 and 1. So 1 by 1, you close. Always secondary must be put in brackets. So which will give me negative what here? Negative 5. So the answer is supposed to be negative 5. Negative 5. Thank you very much for all those students who tried this. That was quite nice of you. So now come and give me the minor elements of all the others. Of all the others. Give me the minor elements of all the others. So Lenny Langati is saying the next one is negative 3 again. I like such confident students. Michael Ikube is saying it's supposed to be negative what? Negative 4. Michael Ikube, at first he had gotten it as negative 3, but he has changed his mind and said, sorry, it's supposed to be negative 4. But for the many years that I've marked these CASNEB exams, I know most of the times when you see a student canceling an answer and writing another one, chances are the earlier one that he canceled is correct. So let us see whether the same will apply to our friend, Mr. Michael here. So Fred, I'm getting back to you. Do you have here this figure for minor element for the 5th value? Is it supposed to be minus 3 or minus 4? There is somebody who is giving us negative 9. Paris is getting negative 9.
9.
Fred, is that your case as well?
Yes.
Negative 9.
Yes.
Abdi. Abdi, unmute Abdi.
Negative 9.
Negative 9, eh?
Yeah.
Aha. Very good. Let's see where these students of mine who are following me so seriously on Facebook, where did they get it wrong? Remember the figure whose minor element we want is this minus 1. So please cover it. Cover that minus 1. If you cover it, what's going to happen? You're going to have this covered row-wise and column-wise. And then if you do that, you'll also realize that we have these left elements, primary elements. First of all, you start by tracking down the primary elements which are left uncovered, which will be 3 times minus 2 product. Minus the secondaries. Of course, if these are your primaries, the secondaries will be 3 and what here? 3 and 1. Then this one here gives me minus 6 minus 3, which gives me negative what here? Negative 9. Negative 9. So please, Lenny, Michael, don't get discouraged. It's all about what here, just a mix-up of signs, but I'm so sure within no time you'll be the ones who will be giving us the correct figures. So please now move on to the next one and give us an answer. Mr. Dixon, how is your experience with this system? With the system, how in this case here are you getting along with this system, Bonner Dixon? Are you able to hear me? Please unmute him. Okay, somebody now give me the others very fast. What do we have here? Can type your answers. Negative 2. Is there somebody who's getting negative 2? Fred. I can see Paris has gotten -2. How about the others? Mr. Fred, I'm so sure you must have finished. Are you getting -2 as well? Now I'm not able to hear Fred. Yes, Fred?
-3.
-3.
Yeah.
Let's then compare these again, all of us. So here we are. We want to hide this -2. So in this case here, no, this one here, the 4. What we need to do is to cover it row-wise and column-wise. If I cover it row-wise and column-wise, I'm able to see the primaries left out. It will be 3 times 1 minus, of course, if these are my primary, then my secondary will be 3 and 2. So then this will be 3 minus 6, which gives me minus what here? -3. Fred is correct. -3. -3. Now from there, ladies and gentlemen, please go to the next one. Now the last row. The last row now, you should be able to give me the minor elements of these figures really without getting any wrong. So how do we get the minor element of these 3? You cover these and the column. You cover the value row-wise and column-wise. So the moment I cover these row-wise and column-wise, I'm able to see the primary which are left uncovered, 2 and 4. I can even see the answer of this quite fast. Who is able to give me this answer? Somebody. Please, if you are not getting these figures right, don't be discouraged. Quantitative analysis, ladies and gentlemen, getting it wrong here and there is part of the game. It is part of the game. It is part of the game. So please give me this particular minor value. Minor value, minor value. Minor value. Yeah, I can see Paris getting a 9. Abdi, do you also have a 9 there? Unmute Abdi.
I got 9 as well, Malim.
Thank you very much. How about my online followers? Lenny Langat got 9. Ikube Michael got 7. Now, Ikube, look at this. You see, we want to get the minor element of these 3. What do? You hide it row-wise and column-wise. And if you hide that figure that way, we'll be left with what here? We'll be left with this submatrix. So once I have that submatrix, ladies and gentlemen, there, what I'll do, I'll come and have my primary. My primary is 2 times 4 minus secondary. Secondary then is minus 1 times 1. So then this will be 8 minus, into brackets here, minus 1. Minus and minus gives me a positive sign. So 8 plus 1 gives me 9. That gives me 9. Gives me 9. If you use a calculator, you don't even have to be remembering this concept of body mass. No. If you have a good calculator, you should be able to get the others, this figure quite easily. How about these other 2? Somebody let us finish it on a high gear. These 2, please give us these figures. What do we have here? Somebody. Thank you very much. Michael is saying he has seen his mistake. Lenny Langat, the fastest, has got a -18. Is that correct? Bona Fred Macau. Is -18 correct, Fred?
No.
No. What figure are you getting, Fred?
I'm getting 6.
6. How about Abdi? How about Abdi? Abdi, what are you able to get there?
-18.
-18.
Yeah.
There is Mumbi. Paris.
I'm getting 6.
You're getting 6.
Yes.
Aha, quite interesting. Quite interesting. Let's see. So remember the figure is here. This is the figure which they want us to find its minor element. To find its minor element, what should I do? Hide it row-wise and column-wise. And if you do that, you'll be able to see, ladies and gentlemen, your primary. Primary is 3 and 4. That gives me 12. Secondary, we have 6 and 1, which gives us what here? 6. So then 12 minus 6, that will give us what figure? That will give us 6. I don't know how they are able to get this minus 18. And to believe there must be a mix-up of signs there. So this is supposed to be, ladies and gentlemen, this one is supposed to be positive what? 6. Positive 6. Now, could we get the answer for the last one and ensure that all of us will be correct? Lennis Langat is giving me a figure of 9. A figure of 9. Langat is giving us a figure of 9. Let's see. Aha, I'm getting back to my students who are on Zoom simply because they have been able to pay after school, the 3-5, which is quite beneficial, very good for us because you're able to put up these resources here for many people. Mr. Fred, what figure are you getting for as the minor element of the last one?
Negative 15.
Negative 15.
Yeah.
Just like Kenya Junior. Kenya Junior has got a negative 15. How about George Simiu? Okay. How about, no, Jenny Kemunta has just joined us. I'm so sure perhaps she's trying to get a footing nicely. We have Paris, yes. Paris, what figure are you getting, the last one?
Negative 15.
Negative 15. Langat is still insisting 9. 9. Let's see, Langat, you must be having a problem with the signs, but we shall overcome. That's the most beautiful thing. Junior got that one a long time ago. I mentioned it. Negative 15. Let's see. Let's see the last one. Great. So see a paper like quantitative analysis, which is a paper that I've taught for the last 20 years. And I normally get awards every semester. It's a simple paper. It's a simple paper. Once you just master a few things here and there, you'll be at home. Just get a concept, practice, do the mocks, do the exams. You will be able to pass this paper in the very first round. We don't want students who keep on taking up these papers. This is not a paper that you should do 2 times, no. So here we are, we have 3, 2, 1. We have 6 minus 1, 4. We have 3, 1, and then minus 2. What do they want us to do? They want us to give them the minor element of this. What is the rule? The figure whose minor element you want, you hide it row-wise and column-wise. And then now you'll be left with this sub-matrix. From the definition, a minor element is the determinant of the sub-matrix left. How do we get the determinant here? First of all, product of primary. This will be 3 times minus 1 minus product of secondary, which will be 6 times 2. So then this will be minus 3 minus 12. Minus 3 minus 12, that gives me negative what here? 15. So this is supposed to be negative what here? Negative 15. Negative 15. Negative 15. So now, ladies and gentlemen, we are through with number 1. We are through with number 2. Now I want to go to the core factors. How do we get the core factors? How do we get core factors? Ladies and gentlemen, core factors, we normally get core factors from minor elements. What have I said? I've just said that we normally get core factors from minor elements. By doing what? By changing signs. Ladies and gentlemen, I'm repeating again that we normally get our core factors from minor elements using, so core factors, we normally get them from minor elements using the diamond rule. using the diamond rule. And this is what I will do for me to get my diamond out nicely. Remember, this diamond normally passes through the central elements. It passes through the central elements of external rows and external columns. So we have like that, like that, like that. It only goes through external rows and columns, central figures. And what we shall do is to change signs. You change signs of elements, in this case here, which happens to be having corners of the diamond, corners of the diamond, corners of the diamond. And if you do that, you'll be able to get your cofactors. So the cofactors here, of course, this doesn't have a corner, so it remains. This has a corner, so we have here 24, it becomes positive. This doesn't, 9. This becomes positive 5, negative 9, and then we have positive 3, we have 9. This one here has got a sign, or the corner, so sign has to change, negative 6. And then lastly, this has nothing, so minus 15, like that. So now we happen to be having the cofactors with us. I don't know whether there is anyone who has a question. There is a student here who is insisting that the last figure is supposed to be 9. The last figure, I always like going back, that the last figure is supposed to be 9, this figure here. Let's again confirm. It's important to confirm, ladies and gentlemen. So what do we have? We have this figure. We have to cover it row-wise and column-wise, right? So once we do that, what is the product of the primary diagonal? Primary diagonal is here. So we are talking of 3 times what here? 3 times minus 1. That is product of the primary diagonal. Minus product of the secondary, which will be 2 times what here? 2 times 6. So please don't rely on doing a lot of multiplications. Always rely on your calculator. You'll never have a problem with body mass. You'll never have a problem with body mass. Nevertheless, so 3 times minus 1, that gives us minus 3, minus 2 times 6 gives us what here? 12. So what is minus 3 minus 12? Sincerely, this will be minus what here? 15. It can't be 9. It cannot be 9. Very good. Very good. It's minus 15. Even Ikube has been able to confirm that. And I would want to see whether Robert will be able to get that figure. But I know the problem normally is in the body mass. And if you want to run away from body mass, always use your calculators. It is programmed with the body mass. Any question before I go to the last area? Any question before I go to the last area? Please, for the students who are in our classroom, you've got so many ways that you can use. You can raise up your hand. I'll be able to get to you straight away. You can type a question there. We'll be able to pick it very fast. Yes. Now from there, the last step is a step of, ladies and gentlemen, universe definition. So come and define the universe. So universe definition. Universe definition. Universe definition. So how does our A universe look like? So A universe will be equal to, we have here 1 over the determinant times the cofactors transposed. Quite interesting. So our A universe will be equal to 1 over the determinant, which we got much earlier. So 1 over 51 into cofactors, these cofactors, but this time around transposed. To transpose means changing rows to become what here? Columns. To transpose a matrix, I'm repeating, means changing rows to become columns. This is the first row. So it becomes my first column. So we have minus 2, 24, and 9. Second row becomes my second column. So we have 5, negative 9, and 3. The third row becomes the third column. So we have 9, we have minus 6, and then we have minus what here? Minus 15, like that. So what have we said about, ladies and gentlemen, transposing a matrix? It means changing rows of that matrix to become what here? Columns. To become columns. Any question? Any question? Any question? So now, if you allow me, I will take you to now an area that is examinable. You see, QA examiners can never give you this kind of a matrix, and then they ask you to give us an inverse of that matrix the way we've done it here. No. They'll always go for the application. They'll always go for the application. So how do we apply this particular concept in input output? When we began this, we said our objective is to ensure that we shall be able to answer a question of input output of a 3x3 form. Now, so I would want you to mention their input output model. They brought it last semester, ladies and gentlemen, and that was a 2x2 model, a 2x2 model, which was quite easy, where they had given us two sectors, if you remember. We have our sectors. We have sector A, we have sector B. We have A, B, we have what they were calling final demand. So we have here our outputs here, and then we have our inputs here. So of course, if A, for example, was to produce, if A's output, for example, is 100, out of 100 that it produces, of course, it must consume a few of them. There must be what we call the internal demand or intermediate demand. So if A, assuming consumes 10, we have A, in this case here, selling to B, selling to B, selling to B, in this case here, for example, 20. And then we'll have, in this case, ladies and gentlemen, the entire 70 to balance this, going straight away to what we call final demand. What flows out of the sectors to be consumed. So if, for example, we produce, if, for example, A is an agriculture sector, we have produced 100 bags of maize. We'll have some of these bags of maize going to agriculture itself, perhaps as seed, some of them going to agriculture itself, perhaps to be used as seeds for future productivity. And of course, we'll have also A selling to other sectors. So whatever that goes to the other sectors is what we call the intermediate what here? Demand. And then now we have the final demand, which is that portion of this total output, which now will not go to any sector. It goes, in this case here, comes to us, consumers, for consumption. What will be exported? What will be stored at KPCU for future usage? So we have B, perhaps B has produced 200. It goes ahead and gives A perhaps 5 bags only. And it goes ahead and consumes itself perhaps 10 bags. Then the balance has to go to the final demand. So final demand here will be 200. 200 minus the intermediate demand. So this gives me 100 what here? 85. So ladies and gentlemen, if you're given this kind of information, what your examiner will do, he'll come and tell you required here. Then he'll tell you that if the final demand of A and B changes to 100 to 100 and 150 units respectively, determine the new outputs, determine or forecast the new output. I would want in this case here us to start with, ladies and gentlemen, a 2x2 matrix first, so that we can acclimatize ourselves with what happens in this model called input-output model. So ladies and gentlemen, if I'm given this kind of a question, even before I remember the model, there is what we call the fundamental principle of input-output, that the total output must always be equal to the total input. That is the first thing. That if A produces 100, then we must have put in an exact equivalent of 100. There are no profits to be generated in input-output models. So if the total output of A is 100, then the total input of A is 100 as well. And then we have B, the total output here is 200, then this one here gives me what we call 200. So first of all, ensure balancedness. Ensure that the total output and the total input are what here? The same. So what have we said, ladies and gentlemen? We have said the most important thing that we have said under input output is that balancedness is the first thing. Ensure that your question is balanced. And for us to talk of balanced questions under input output, even as the model tells us input output, the total input must always be equal to the total what here? Output. Total output. So that's what I exactly have done. Total output here, then you have the total input like that. I hope that is clear, first of all, because without you appreciating that, then the vehicle you have boarded here will not take you anywhere. It will be just, will be on a road to nowhere. And as I told you, I've taught this paper for so long, I even doubt whether there is any lecturer in this town who has taught this paper longer than me. Yeah, great. So I know exactly what these examiners need from you for you to be able to do what here to survive and even get an award. This time around, we want to produce an award out of, or rather from, our online students. We would want to, one of these fine days, this semester, to produce an award winning student from these classes online. Very good. Now, of course, I know that if you look at this particular column, like the first column, 10, 5, we are not seeing that the two cannot add up to 100. The two are not adding up to 100. We know that the balancing figures are supposed to be called the primary inputs, but we don't want to go there. For now, what I want you to do for me, come and give us what we call the input ratios. You'll get some books, in this case here, calling them technical what here? Coefficients. Technical coefficients. Technical coefficients. Technical coefficients. Matrix A. So how do we get our input ratios? To get our input ratios, come and work with these figures here downwards. Like now you will talk of 10 over 100. Here we have 5 over 100. 100. When you go to column 2, the benchmark will be 200. So this will be over 200. This will be over 200. I only want the sectors proportions. So then this will be 10 over 100. That gives me 0.1. 5 divided by 100. That gives me 0.05. 20 divided by 100. I know the answer, but I always like trusting my calculator. 0.1. And then we have 10 divided by 200, giving me a coincidence, 0.05. So this is my matrix A. Once I have my matrix A, the next thing will be for us to get to what we call the Leontief's matrix. For prediction, once you get your technical coefficients, go ahead and give us the Leontief's matrix. Leontief's matrix. Ladies and gentlemen, for those of you who have not known where we come from, this is AfriSchool. AfriSchool basically is a provider of online tuition. We have recorded videos like this and put them in our website, where once you pay us, you will be able to access all these videos. And of course, for us, we have this kind of live interactive classes. And of course, if you recall, this Mwalimu teaches at RCM. He happens to have written so many books. So you need to accompany your studies. You need to complement your studies by buying these revision kits or study texts. Study texts will be able to complement your online studies very well. Thank you very much. Now, ladies and gentlemen, we have here the technical what here? Coefficients. Once I have this, we've said that the next thing will be for us to do what? The next thing, ladies and gentlemen, will be for us to come and give our examiner the Leontief's matrix. Leontief's matrix, I can see Emmanuel Rotich. This called Leontief. Leontief like that. Leontief's matrix. Leontief's matrix. Leontief's matrix. Leontief's matrix. Thank you very much, Japheth Avengers. These are somebody I taught somewhere very long time ago. He's saying, I agree. Thank you. So remember, for forecasting purposes, the model that you're using is called Leontief. It's called Leontief. So remember, for us to be able to get the total output, ladies and gentlemen, X, how do we get this X? It is I minus A raised to minus 1 multiplied by our new levels of what here? Final demand. Multiplied by our new levels of final demand. This I minus A is what we call the Leontief's matrix. So I minus A. I is the identity matrix. So identity, given that the A is 2 by 2, our identity will be 1, 0, 0, 1. Minus our matrix A, which is 0.1, 0.1. We have 0.05, and then we have 0.0 what here? 0.05 like that. So please go ahead and subtract for us to give us the Leontief's matrix. So when you subtract this and this gives me 0.9. This will give me minus 0.1. This will give me minus 0.05. This will give me 1 minus 0.05. 1 minus 0.05. This will give me 0. What here? 95 like that. So I don't want to forget these final demand figures. For A, the final demand is 100. And then for B, it's 100 what here? 50 like that. So please ask questions, ask questions. Ask questions, ask questions. So now remember that after you have gotten, ladies and gentlemen, this Leontief's matrix, you've been able to define the I minus A matrix. The next thing as per the formula is for you to inverse it. And how do you get to inverse this? It's quite easy. They want us to inverse this, which is a 2 by 2. So to inverse this, the first thing you'll do is to give us a determinant of I minus A. So determinant, remember, it's product of primary minus product of secondary. So could you kindly give me an answer here? It will be 0.9 times 0.95 minus open brackets, ladies and gentlemen, for the secondary. So secondary, what do we have here? Minus 0.05 times minus 0.1. So please come and give us an answer. So we have here 0.9 by 0.95 minus open brackets minus 0.05 times minus 0.1. Minus 0.1, which at the end of the day, ladies and gentlemen, will give us 0.85. Is there someone else who is getting a similar answer, the same answer with what Mwalimu has? I can see Paris had already gotten it as 0.85. Now, having gotten that, come and define the inverse as per this. So define the inverse as per that, ladies and gentlemen. Our inverse here will be I minus A raised to minus 1. I minus A raised to minus 1, which will be 1 over the determinant into what do we normally do in our brackets for 2 by 2 matrix. Remember, 2 by 2 is not as rigorous as a 3 by 3. A 2 by 2 matrix is a straightforward one. Who can remind us? Is George with us really? Mr. George. Mr. George nowadays is not able to. The rules of inversing a 2 by 2. Michael Ikube got 0.85. That is very good. George Simiu says 0.86. I don't know why it's supposed to be 0.85, George. Just confirm again, George. Michael has 0.85. That is very good. George has 0.86, which is not right. Is not right. I'm so sure George will be able to click that in a moment, because the figures are here. Even yours is not about body mass. The figures are here. Use your calculator. You'll be able to get that 0.85, which Paris got long time ago. So remember, for a 2 by 2 matrix, ladies and gentlemen, never go for the adjoint approach. For a 2 by 2 matrix, once you have your 1 over determinant here, get inside the brackets. Inside the brackets, what do we do, ladies and gentlemen? Inside the brackets, you interchange the primary elements. So we have 0.95 and then 0.9. And then, ladies and gentlemen, for the secondary elements, you leave them where they are, but you change their signs. So their signs, we have here 0.1, and then we have 0.05 like that. So then, ladies and gentlemen, by doing this, we happen to be having our Leontief's inverse matrix. Leontief's inverse matrix. So after getting that, ladies and gentlemen, then the next thing will be for us to come right away here. And plug in the figures that we have here into this formula. So we are saying that our x will be equal to 1 over 0.85 into 0.95 into 0.1, 0.05 into 0.9, multiply this by final demand. Multiply this by final demand. Multiply this by final demand. So final demand, ladies and gentlemen, you were given here final demand figures, 100 and then 150 like that. So I would want to see whether we have serious students also on Facebook who will be able to multiply this thing for us and give us answers. First of all, we ignore the scalar. Let's ignore the scalar. Let's try, ladies and gentlemen, to multiply the two matrices first. So on Facebook, I expect you guys to give me the first product, row 1, column 1. Okay, so let's see how they are multiplying. Remember, whenever it comes to matrix multiplication, always remember Roman Catholic. Rows are multiplying what here? Columns. So like now we have here what we used to call in high school, running down the ditch. You run down the ditch like that. So we'll have our x, of course there are two of them, x1 and x2. First of all, we talk of x being equal to 1 over 0.85 into, so we have run down the ditch. We have first ones multiplied. So 0.95 and this is the first ones, plus second ones multiplied. So plus 0.1 times 150. Then this row as well multiplies the second column. So we have 0.05 times 100 plus 0.9 times what here? 150. So then this one here will be 1 over 0.85 into, so please multiply this for us. We have, I can see George Smew has given me figures there, 0.95 times 100 plus 0.1 times 150, which gives me, I'm getting 110. The second one will be 0.05 times 100 plus 0.9 times 150, which gives me 140. So from there, what I'll do, I'll come and distribute the scalar inside. So it will be 110 times this, which will be the same as 110 divided by 0.85. This one here will be 140 divided by 0.85. 110, 140. Very good. I can see Emmanuel saying something very nice. I'm buying a calculator, a book, subscription to your web, and I study a table tomorrow. Thank you very much. That's quite positive. So then 110 divided by 0.85, 110 divided by 0.85, that gives us 129.41. And then 140 divided by 0.85, that gives us 164.70. Ismail got this very well, 110 and 140. Very good. Now, ladies and gentlemen, I can see I'm really running out of time, and I would beg that you yourselves at your own time, try looking for this. If A is 0.1, 0.1, 0.3, 0.2, 0.4, 0.1, 0.15, 0.21, 0.32. And then they have given us demand is 30, 60, 80. Please put this down, and then you are required to give us X, like that. You're required to give us X. You're required to give us X. You can see now these are 3x3 scenario. Eh? So please take like a minute, you copy it. For the students who are following us on Facebook, we are trying to come up with an innovative product for all of us, which can be fair for all of us, where we shall be providing live classes to you at a very subsidized rate. So you can talk of like how much do you pay for each class? How much do you pay for each class? Should you want, for example, pre-recorded videos, then you go and purchase again the pre-recorded videos at 3,500. But for now, we should be thinking of what good price do we give to Mwalimu every time he has an online class. You can imagine, like right now, I'm finishing my classes this time round. I have to go home. I have, in this case here, to beat the curfew rules to be home. I also need some resources, honestly. Thank you very much. Good night.